Hello guys, today we are going to work with the educational booster pack from the Texas Instruments, specifically with the light sensor. We are going to use the I2C communication and also the UART to send the information to the PC. In this picture, we can see the location of the TI OPT3001 LED sensor. We're going to pull the information from this sensor as it will be explained. The I2C is a synchronous bus made of two wires. They are connected by default to high through the resistors, as we can see in this picture. It allows multiple slave devices and also multiple masters, but only one master is going to be dominant in the communication. Each device has its own I2 address, and they all work with the same clock that's generated by the master device. We can see that one of the lines is the SDA, serial data, and the other line is the serial clock, SCL. All of the devices that are communicating through I2C are connected to those two lines. Remember that I2C is synchronous. That means that all work with the same clock. We can see from this picture that the start and stop signals happen when the clock is high. The start signal happens when the clock is high and SDA falls. Meanwhile, the stop signal happens when the clock is high, but the SDA rises. The communication in between is allowed when the clock is low, so only start and stop happens when clock is high. This is the block diagram for the light sensor. The idea is to find the I2C sensor's address and also the internal registers. For example, result, configuration, manufacturer ID, and device ID. Those are important registers that are specified in each device datasheet. And also remember that there is a pointer register that's always going to point to the last register referenced. For example, if we want to configure the sensor, the first byte sent needs to be 1 byte corresponding to the address of the configuration register, but that byte goes to the pointer register, and then the next 2 bytes are going to the actual configuration register. So before we run the code, we have to open the Composer Studio terminal and configure it to COM3 and the baud rate that we want to use. In this case, it is going to be 9600 Hz. For our first experiment, we are going to read the device ID and manufacturer ID registers in an infinite loop. So there is a counter that's always going to increase by 1 and will always read the same two numbers that corresponds to device ID and manufacturer ID. For the second part of this experiment, we are going to read the content coming from the sensor results register, and we will transform it to logs. Now we are reading the results register, also using an infinite loop. So every time we sample the results register, the counter is going to increase by 1, and we're going to read the result in logs. Because we chose the exponent 7, we have to multiply the data content of the register by 1.28, and the result should be in logs. We can test this just by putting our hand on top of the sensor, so the light is going to be blocked, and we will read like the lowest logs. And if we put our phone light or just like some kind of light source on top of the sensor, we are going to read a higher, or almost, if it's very close and is a high intensity light, is going to read the max logs possible. Thank you guys, I truly hope that you enjoyed this video, and I'll see you tomorrow. Take care guys.